All right. Yeah. Hey, welcome to Coffee Compiler Club the day after Thanksgiving. We're all sort of overdone our eating and are still recovery mode, or at least those folks in America doing Thanksgiving. I guess there's a lot of Europeans here too who not the same thing. Anyhow, gonna see if we get a little bit of compiler stuff done. And I am going to share to start the conversation. Well, here's Levo. I'm going to get Levo connected, and then I'll share a little tiny bit about compiler IR debugging printouts. Why? Because compiler IRs are always complicated, difficult things. And what do you do to debug such things? So here is a sample. Actually, I'll put it in the docs, and maybe I'll put the docs on here. I'll share the docs in a second. Boom, here's something. Where's the doc share button? Zoom, wherefore have you abandoned me? Share, docs, share. Hey, okay, so you probably actually want to see, this is probably code that came from, oh, not quite this version of code. Where did this come from? This came from something related to this. Let me push that in the docs as well. Now that I've lost the docs. Here we go. Code for copy. I need another copy. Da, 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 da. You bastard. Boy, Google is just being a bitch to me. I don't know if I am not got my fingers functioning yet. All right, now I have to go back and cut and paste again because it was so bad. Here we go. How about that? Oh, look at this. Okay, so fine. So all I got here is some stupid piece of code. Here, I'll pre-optimize. I don't care. So the piece of code says, A is 1, A less than 10, A plus equal 3. Fine, wherever it came from. Somewhere right above here, I have an IR dump. Starting from the top down, like cut and paste errors. There's a start, there's an incoming argument, which in the language of simple, we only have exactly one, and it's only an integer, because some future date will fancify it, but it ain't happened yet. And let me make sure okay, fine. And then, and there's a control input, which tells you what executes next. There's a bunch of constants, which have been hoisted to the top of the program because there's no optimizer. There's just a compiler IR. There's a loop, which is basically also called a region and a program dependence graph, if you will. It's a merge point. There's a phi function that's got a suggested A label. It's just for debugging, some add, some less than, if, true, false, return, fine. Every node has got a node number on its left, which shows up as this is its self number. This means it's on its inputs. So arg has node number 2 as an input. Loop has node number 4 as an input after skipping one. So that's just a null in the IR. 4 is the control, who has his input 2, which comes from start. The loop has a 13 as another input. That's the true side of the if test down here. The true side of the if points to the if itself with the 12. The if has a 7 as an input, which comes to the loop, and that's your loop. So there's a loop in the graph. The square brackets tell your outputs. So this is just the other direction on the same edges. So this is your edge and the nodes and edge format. So control has an input for 2 and an output for number 7, the loop. The loop, in fact, has an input 4, which is the control, plus some outputs. 1 for the phi, 1 for the control for the looping, and so on. So that's the current proposed printing output. This is probably done with some variation of reverse post order, except I've done special hacks manually to deal with loops and the if true false. And in general, when you get big ass IR dumps that span thousands and thousands of nodes, these kind of printouts become extremely handy to discover what's going on, where the optimizer screwed up, what happened, why is it broken now? You only use these debugging prints because you got bug. So they have to be robust in the face of like crappy IR, like the IR is just broken. because that's the whole point. And you're here because it's broken. And so it has to be robust. It has to be informative. It has to be fairly dense because you're going to dump thousands of them. And I sit in my debugger and I hit the eval thing and I say node x.print of a depth. I give a depth like 99. It's just like a whole program, or 2 or 3 if I just want a little dump. And I stare at the output and decide I know what my graph looks like. Okay, why am I not using a graph visualizer like GraphViz, which we totally have hooked up into the simple stuff? Because as the programs get bigger, graphs become uninformative. They don't help you debug. They give you giant piles of pretty eye candy, and there's no hint for debugging. So I need an ASCII print. And this was just this week. So I was going to do it earlier in the week, and of course, Thanksgiving, so fine. And so Duendo did some hacks, and I've done some hacks, and I wanted to see if people here do debugging printouts of IRs using ASCII dumps, and what, if anything, they like about their particular dump versus what I'm doing. Does anyone want to say anything here?
Yeah, I can say. I don't have ASCII dumps in my compiler. Sort of. What I have is the ability to export the mid-level IR, which is where most of the interesting stuff happens, to a set of GraphViz files, specifically dot files, which you convert to PNG, and so you get a basically a graph of all the basic blocks per method, per module, and that's what I do. That's been very useful so far. Okay, let me see if I can copy. This may or may not copy what I want here. I have a GraphViz. That's not gonna work. Let me copy image and see if that works. Yeah. So this may or may not be the same as what we were just looking at. It's not. Okay. It's not the same graph as what I showed above, but the point is I can do this. I have found in times past that this size is fine. Double, triple this size is fine, kind of. As I get to like 10 times this size of graph, it becomes less helpful. When it comes to 100 times that size, it's just like a sea of nodes. I have no intuition of what's going on.
So I usually have multiple different like dumping tools. Depending, so like if I'm running through like people optimizations, I've got this visualization. Let me see if I can pull it up in the Google Doc. But essentially, I've got a visualization that looks something like this. Let me pull it up.
Yeah, open a blank copy block below and throw it in. Like you can see in that GraphViz there, GraphViz doesn't understand loop structures well. So the region should be the top and the if should be the bottom below it. But it's not. The GraphViz isn't helping. Yeah, okay, that's actually pretty clean there, Yorick. I have to zoom in so I can see. Yeah, apparently Google Docs doesn't let you upload SVGs, but they spit them out as SVGs, and then you can just zoom in as much as you want.
Are those like traces or something?
No, that's let me see if I can dump the SVGs somewhere.
I'm trying to figure out how to zoom it so that viewers elsewhere can like see it here.
Let's see, what is the easiest? Yeah, it's kind of annoying that it doesn't let you upload SVGs.
Wow.
I'll dump it on Imager. Hold on.
Okay. You can give me a link, and I'll switch links to a browser link and use the browser to keep viewing.
That's, by the way, that's like this situation right here is 1+ point for the ASCII dump.
Okay, Imager doesn't SVG either. I'll dump it on an S3 bucket.
Okay, so is I'm sorry, is this Adrian was saying this was your dump here at the bottom?
What? No. I was saying like this situation we have right here is a like +1 point goes for the ASCII dump because like dealing with SVGs is a pain. But if you have an ASCII dump,
yes, like I said, I can pull the view up. It's still a layer in direction for me because from the debugger, I want to see something. I open up an eval, I type something, and I don't necessarily get. I could screw around and get a dump from the debugger. I want to get a dump from the debugger. Eval, fucking GDB of years past, hotspot, C2, I'm dealing with 10,000 to 100,000 nodes all the time. That's the daily workload. You dump into an Emacs buffer. And then the Emacs search, cut, paste, staple, fold, mutilate, run macros, blah, blah, blah. Fine. Now I get an ASCII dump into an ASCII buffer from IntelliJ, and it's okay. It's mostly what I need. I can search in it. And when it gets more searchy than I want to do, I cut and paste it into an Emacs buffer and life goes on. ASCII dumps? Not ASCII dumps. SVGs? I can't. Let me go test. Let me go test your SVG here. Oh, he won't even. Oh, come on. Yes. Hey, zooming. No, not zooming. Wait, how about Control Plus? No? Control Plus?
That should work, yeah.
Okay, allocate a thing. Say true, move, nil. This is like low-level assembly code then.
Yeah, this is basically the mid-level IR. It's
Okay, well, how is this one function or several?
No, so each sort of white rectangle with like the name at the top, that's one method.
Yeah,
and
so
then
one
the
function,
yellow
one
with
method.
grays are the basic blocks.
So these are all tiny. You gotta dump.
This was something I was working on a few days ago. I just still had it around.
Okay, so you have a graph version of an ASCII dump, basically. This is an ASCII dump line by line.
No, so what
happens
happens basically there's a mid-level IR, that is a graph, if you know basic blocks, the usual.
Yeah, right.
There's a flag in the compiler which basically takes that IR, dumps it to dot files, and those are text-based.
Right.
You can then convert them to SVG, PNG, whatever.
Right, but you're converting a control flow graph of basic blocks.
Yes.
Okay, that's what I was saying. So I was looking for something with a larger control flow graph. These are all straight line, one shot. There's one little branch around down here at the bottom.
Yeah, I can get one. Just give me a sec.
Like kind of get the biggest sane one you want to go ever attempt to debug, because that's the question. Is like, when does it become not helpful to have a graph layout? And maybe it's always helpful when you're doing a graph of basic blocks, as opposed to sea of nodes, which I have here, which I don't have any basic blocks on purpose. And already there's hoisting and code motion sort of indirectly happening for free out of the damn thing. So you don't get such a nice basic block thing. And who's doing the block code at the bottom? Is that Adrian
that's
or
me.
Yasser?
Yeah, so this is one, or actually this is technically two of the dumping tools. So there's like the people one, which just shows you like what is the people optimizer doing, and then I color it differently.
What, one line per peep doing something?
Yeah, and so it'll be I believe it's green is idealizing, then it's it doesn't show it here because I don't have any identities here, but there is a yellow for, there's like a golden color for identity, there's a yellow for like constant propagation,
right,
red for global value numbering, and then there's like a cyan color for like when like a type reduces into one value, and so
so several things here. You're coloring your text. I didn't think to do that because I was always doing old school shit, but coloring text should just totally work.
Yeah.
So the next thing you're doing is you're dumping one line per peeps. That's interesting by itself. Like I put my peeps on a counter that's deterministic. I can set the counter and binary search a broken peep.
Yeah.
But I don't get the list of peeps before and after in an ASCII dump where I can manually search the peep list for the obvious point where a peep screws up and breaks something. That's an interesting dump.
You can kind of do
because
something.
A lot of like.
Let Yasser finish, then Matt.
What's it called? One of the big ones that comes up is just a lot of people's like usually just touch their direct inputs. So just seeing which numbers line up to like, oh, this node is broken. Let me see, like, let me just Control F the file to see who's referring to this, who's changed it.
Right. What peep touched this node right after it? Yeah. Okay, Matt. Matt, what were you saying?
So you can do something similar in LLVM. So first of all, you can of course dump LLVM IR after every single pass, and you can see which pass is doing what. But there is this new option which allows you to use a diff format, like in a Git patch. So basically, it's going to show you what has changed in the IR, which line was added, which line was removed, and how was it modified, as if it was a patch. And it goes pass by pass by pass. So that is kind of convenient, especially if you are debugging something going wrong. This is one thing I do like about this LLVM IR is that for debugging, it can be pretty good. I can see if I can find an example of that one.
Okay, yeah. I mean, I have different strategies over an LLVM IR that I'm using for peepholes, including the binary search I just mentioned. But I hadn't done the one line per dump for peep. That's interesting. And then I'm going to open up, here it is, Yorick's other one. I claim Yorick, this is still on the small end of what I would typically deal with.
Oh yeah. There are bigger ones that have to go digging, but the bigger ones can get a little annoying to look at. Yeah.
Well, that's the point of the graph thing, is that it schmews on. The other part is, of course, I can search. Like if I'm looking at the SVG text description format, I can search it.
Yeah.
If I'm looking at the graph, I don't know that I can.
Here you can search. Like if you do Control F, it will search through.
That's raw text fields in here.
Yeah.
Oh, it is. Okay. So you can search the text for like, where did R15, well, R13 tag came from? Okay.
Yeah, that's something I do quite often, actually.
Ah, yeah, okay. Oh, that's helpful. That's 90% of it is search. And then sometimes I get fancier macros or fancier flavors of search. Usually when it gets big, I have to track something through. This came from move 10, which is busted. Oh, where'd move 10 come from? And then backwards and backwards and backwards you go.
Yeah, that's basically what I do. I just use, I mean, not quite pen and paper. It's like a fancy Etch-a-Sketch, basically.
Yeah.
Yeah, pen and paper for all intents and purposes.
Oh, this search doesn't work well.
Do you guys mostly use this to find like which step broke it and then go back in the debugger, or do you actually debug these?
I usually use it to find the step that's broken. Like I stare at this pile of peeps that Yasser's got here, and somewhere in there I've decided I'm getting close to the breakpoint. Well, I have a counter that goes with it. Like he's got T equals 6, 7, 8, 9, 10. Okay, I was up in the thousands commonly.
Yeah.
So I set my counter to whatever 1,000 I want minus a few. And then I go dump the graph a few before, and then I step over the peeps and I look at which peep's firing. And usually there's an obvious suspicious peep. If I'm already down to where the break happened, there's an obvious suspicious peep, and I go in, and then you discover some prequel was not set, or I failed to get it incremental because I didn't touch a neighbor and it should have fired first or later or something. There's something stupid happened. Once you get to the direct peep, it's usually pretty obvious. Getting to the peep, like I said, I've often done binary search on the peep numbers.
I've added a screenshot of my mini VM generating sea of nodes.
There you go.
It doesn't, like, I don't want to look through that. I don't want to like look all through that. I really don't.
Right. This is the problem I have with large graphs. If you put that on a website, I can zoom and we can let our audience see the zoomed version. I can't zoom it in the Google Docs.
Like sorry, I'm talking and I'm muted. Dot gives me like that image. It doesn't let me like it's blurry for me.
Oh,
Dot. Oh, I told it to give me a PNG, but its PNG was not big enough.
No, the PNGs and Dot are terrible because they're also quite blurry. If you're an HIDPI, that's why I use SVG because it's the only one where it doesn't look like crap.
Let me get you an SVG here.
Yeah, that'd be very cool.
Yeah, I shared a picture of the stuff that Matt was talking about with like the LLVM div stuff because godbolt has it.
If you send me, if you put a link in the doc, I will chase it for godbolt links. And we can go.
I just shared like a screenshot, but I could pull it up and I could pull up a link.
Is that this thing here, right?
Yep.
Yeah. Again, I can't zoom it on Google Docs, so it's hard to look at. Yeah. This is people's piles of optimization passes, and this is before and after transform from like LLVM on that trivial program. I put it in the link section, but no, you actually put it here. This is fine. Might copy it to the link section as well.
All right.
Yeah.
I don't know if it shares. I don't know if it shares the view if I show it to you. Oh, it does. Yeah.
Okay. So somewhere in there, somebody has done what? This is actually machine code. Signed something extended I32 to I64. Okay, sign extends an into a long. And the next one over says ZX ineg. I don't know what ZX is zero extend. What's ineg in the middle doing? Is there an instruction for that?
I actually don't know what that is.
Right. And then on the left, Again, the second red line is ink equals, okay, who knows what that one is? Add not safe for work 1 to, it's I equals I plus 1. And somebody is like, that's the trip counter. And
Yeah,
it's
so that one's
signed versus unsigned. Okay.
So that one's just appending. So the NSW and NUW are just like no signed wrap and no unsigned wrap, and it's just like, oh,
Gotcha.
the loop counter's not going to overflow.
Okay. Yes. So for instance, it won't because it's a 0 check and a less than. You could throw a negative length in there and that'd be fine as well. So yeah, he won't wrap. Yeah, C2 does this kind of crap. Yes,
Yeah.
You won't wrap. I know you won't wrap. Therefore, I can skip half the range checks range. The usual one for C2 is he just does an unsigned range check, but he has to prove the trip counter won't start negative.
Yeah, and apparently the nneg thing is not negative. So the idea being like, oh, it's technically sign extending, but like it's never going to be a negative number, so it doesn't matter.
Right. And that's a hint to the code generator to he can have his pick of various encodings of instructions here because it's all going to be valid. Yeah. Okay. So this is what we're really showing here is the diff between IRs, which for me in peephole lands on a graph isn't so easily visualizable. What I would like to see, and I haven't seen yet, is take that stupid IR. I'm going to go back to the other window here, this IR, and have a peep red line circle who his inputs are, transform within the inputs to the new version, and then fade the red circle out, showing you exactly what the peep is. And then, sit in my debugger and hit spacebar and have it wrap peephole after peephole after peephole while he marches along, optimizing as he goes.
Yeah, I really wanted to do something like that, but every GraphViz tool that I tried to use for animation really didn't like it.
Yeah. Right. I looked at GraphViz for like, can you do tweening or something? Keep this layout, keep that layout. I could probably force a new layout where I grabbed the peephole region in question and forced it into a subgraph of a fixed shape.
Yeah.
And then change within the subgraph and then relax. And of course, as soon as you relax, it'll just explode back into whatever his default layout is, which will be suck. And then you'll grab a different region and force, and it'll just completely warp the graph from time to time, and you won't ever get a small incremental section. Like I can hand roll these small sections and say, oh, in this tiny program, I'm just going to wrap here and one, people here, and it'll fold right up. It'll be obvious. Yeah, graph is not doing that. Sorry, I cut you off. Yes.
Oh no, I was just agreeing with you.
Okay.
But I added a.
I'm eating my protein. Somebody else go.
Oh, well, if you can click things, I was just going to say I made a GraphViz version of what you posted initially. It's in the code block. If you scroll up.
Roll up.
There's a link in the code block to a site called Editor, which is just this GraphViz layout thing.
Okay, hang on. I have all kinds of people hacking the links. I'm still not seeing you. Where is it a link to?
Well, I put it in the code block, so because
in a code block.
Yeah, it's highlighted. So.
This one here says editor.
Yeah, it's editor misspelled, and the link.
Okay, yeah, I'm trying to get there, but somebody's editing above, and my screen is going up and down fractionally second by second. I can't get there. No script warning. Block this request. All right, I'll allow this one.
That's my. I don't know. That's my.
You're not getting. I got you nailed here.
Yeah, no, I was worried about that, but I guess I can't do anything.
Can you not give me another thing here?
Well, that's just say allow this request, or maybe always allow this request.
No, now you're getting hit with no script.
Yeah, and now you're
trying. You're like one of the 5 people who uses no script.
Yeah.
Oh, geez. Okay. Yeah. There you go.
So, I don't know. I mean, that was just like a straight translation. I just said, okay, we know it's like, in the square brackets, I draw an edge to that.
Yeah. I
So it
did.
doesn't-
That's what we're using GraphViz for on the other side, except we've color coded the edges and the nodes and little
Yeah.
shape chain. It still needs a bunch of layout love.
Yeah.
Honestly,
made
this layout's better than what I'm getting off the other guy. We've tried a bunch of layout options on GraphViz and still a work in progress.
Well, like I've discovered the thing that makes GraphViz work really, really well is to not give it a graph, but to give it a tree. So,
Oh,
so like all my IR, it turns out, is actually a tree. There's no back edges, so it lays it out very easily. So
yeah. All right. It's like if you have a well-structured control flow graph, that works. C2 had to deal with, I had to debug arbitrary CFGs. Inlining Java would get you an arbitrary CFG. It would be irreducible loops. It'd be broken, not structured in all kind of ways.
Is it because like an exception could like jump out of multiple loops and then you'd end up with like continuing? I'm sort of trying to follow how that works. So you'd have some loops and then you'd exit from them by throwing an exception, and then that would jump somewhere outside of the loops and you'd continue out
go
there.
into in the middle of a different loop.
Yeah. Oh, okay.
Yeah. So you could, yeah. And because of that, you could get irreducible loops. And that pattern is very common in large enterprise coding, where I have a for loop, it has a try catch finally. Inside there, I have a complicated function call that goes to a for loop with a try catch finally. These are nested 5 and 8 layers deep, just ludicrous numbers deep. Somewhere in there, somebody's hot enough that you start to inline, and then you suddenly get these wildly irreducible graphs. It's ugly.
Yeah, it makes sense.
So what is editor as a page here? What was that editor page? It's just another GraphViz displayer?
yeah, so this is like an online GraphViz thing. You just type in the GraphViz and it renders it.
Yeah, I use an online one for rendering the graphs you see in the middle of the page there. That's an online renderer. I mean, I dump the text file out and then I just cut and paste it. Like in my debugging cycle, when I'm fixing GraphViz layout issues, you can't see that. I dump something, it's printed in the debugger. I alt tab to the debugger tab and I double click to select all, and I alt tab to the browser tab and I control V to paste, and it pops right up. And it's a little clunky, but it's not too bad. But it's definitely GraphViz based ASCII dump on the left to browser window on the right to get the view dumped out. I think we have an internal tool we use for building, maybe. I'm not positive. Like we get images in our GitHub because it's a tutorial and you want the images there. I think the images may come from a tool and not from the browser directly. Not positive. There's an awkward build script going on somewhere.
By the way, I was thinking about the ASCII dump. I generally like it. So I think you could improve a bit on it. I was thinking about this a bit for my IR. I mean, I got rid of my IR. I don't have anything like that anymore. But I was thinking you can just keep the ASCII dump and write it to an HTML file, except the inputs and outputs can be hyperlinks. And then you can jump throughout the entire page constantly to all your inputs and outputs. So you can keep it still simple, but yeah, you get some nice benefits.
So the trick with the ASCII dump is I want to be in my debugger and say eval, hit the eval button, alt to say where the hell it is. I have some node in hand. I want to know what his immediate neighborhood looks like. I got 10,000, 100,000 nodes. I want to say eval node.pre for print of depth 3. And I get a short print of depth 3 around this node. Okay. I would love if that had links, but it goes to the editor's eval window, which I don't know has links.
I see. So you would have to like extend your editor somehow, like
right. If I sat this inside of Emacs using GDB and I said print, I totally make the Emacs buffer do hyperlinks. That would work. Mm-hmm. If I dumped it into a text file and then had the browser pop it open, like whatever, stay camped on this file and reload it when it changes. Then I could alt tab to the editor window or browser window and have hyperlinks. Like the hyperlink thing sounds cool to me.
I mean, I think like having like just creating maybe a way to have hyperlinks in Emacs probably sounds like the more elegant way, because then you don't need to alt tab to a browser.
Right.
Yeah, I was just thinking,
yeah.
because I'm not super into Emacs, so like that thing is too sophisticated to me. So I would just go with the hyperlinks.
So the small form factor, small dumps means I can get away with eyeball search or Control F to go hand search, and that's quick enough. If I had a 10,000 thing, I might be interested in and I did them in C2 all the time. They got the giant dumps, and you were debugging some horrific incremental dominator breakage that allowed some tests to get elided far removed from where it was whatever, and now things are broken and you're trying to find what happened. You don't even know what's wrong, and then hyperlink searching around is actually the kind of thing you'd be doing. That's an interesting one. Okay.
Do you usually stick to dealing with the IR for a single function, and do you ever try to reduce it?
Well, okay. Yes and no, and things are changing. So land of C2, single function with inlines. But C2 will inline hot code aggressively up until he thinks he's not going to get any progress for more inlining. So they were going to be big. Yes, if you had a stupid simple loop, it would be hot all by its lonesome and no inlines are necessary and done. But if you had some giant enterprise crappy thing that went on and on and on, you inlined a lot. So 10,000 was a sort of a target reasonable IR count, but 100,000 totally happened. Okay, so functions were big because they got inlined. What was the other thing you're asking? Oh, in AA, I am building an actual call graph in parallel with the CFG. It's whole program and entirely incremental. And so I do have multi-call things, but I break out my ASCII prints by functions as the user wrote them, because that's very helpful for debugging typically. Typically, user writes a thing that's important in a function. And then it doesn't, the breakage that you put in didn't leave the function boundary. So printing by functions happens as a thing. Like on a normal, do a big print, I'll get it broken out by functions, it's all good. What was your other question? You asked two. I print by function, or I debug by function. I do one function at a time, but the functions are big because inlining. You had another question there, Levo.
Yeah, sometimes when I hit the microphone, it doesn't actually unmute.
Okay.
So I was asking, do you reduce it? Like if you can't find the problem, do you try to reduce the function to reproduce?
Oh, reduce it that way. Yeah, but see, the people's reduce all the time. Oh yeah, totally. Yeah. If I have it, well, here's the deal. If I'm doing test cases myself and I'm bringing up the compiler, the test cases are meant to be reducible, and you reduce them, and you make a new test case of the reduced form, and you finally get your bug. Okay, good. You're debugging somebody's million-line enterprise app. You can't get to the program as a nice, clean, convenient thing that you can manually reduce, because the program will never get there, because your reduced program will just break. When break his million-line app, and you'll never run that far. So I cannot reduce these large enterprise apps, which is why I'm busy in the middle of running your app, stopping to debug the JIT, where I have a 10,000 or 100,000 node IR that I just have to debug this version of it. Having said that, there are a bunch of C2 flags for exactly binary search and reducing functions. Cut out inlining. That usually makes everyone run slow and correctly, and you're all done, and you didn't find your bug. So cut out inlining in this set of functions and that set of functions, and halt at these. Don't compile this function. Do compile this function. Binary search on who you do and don't compile, and you eventually come down from thousands of compilation units to the one that is breaking. Then you can start specifically not inlining on it until it quits, stays just barely breaking. And then you add a bunch of other flags to help with debugging, printing, whatever, and see if it still breaks. And then you bring in the debugger and halt and look at the one function. And it's still big and has all kinds of crap going on, but
it's also useful at this point to be able to reduce the IR itself. And in order to do that, it's good if this IR that is textual, not only you can dump it from every pass, but that you can reload it in your compiler and resume the compilation for whatever was fed to it.
Right, I
very often use this with LLVM IR, where I remove operations that I'm pretty sure, or even entire basic blocks that I'm pretty sure are not gonna influence the miscompilation that's happening. There are even automated tools for that, and then you can just resume compilation and keep chopping off the pieces that do not matter.
Okay. With an ahead of time compiler, this sounds reasonable. In a JIT, if I stop in the debugger, there's a 50-50 chance I can't restart and have the program as a whole work because everybody timed out. All timeouts happen, everyone aborts, everyone throws error messages, everyone hits retries. They're all in their alternative retries. It's all multi-threaded concurrent going on in the background as well. So usually once I halt it in the debugger, I can inspect for breakage, but I can't restart no matter what.
Right, because you are simultaneously debugging the mutator, one could say.
Yes, I'm simultaneously debugging the mutator while it's mutating, yes. So I can halt all mutators, and the only thing it changes is time, but a lot of these
You need a debugger that stops the clock also.
Yes, I would need a debugger, and he has to stop the clock on the other side because they opened up a portal to the DB, and the DB timed him out and closed his link.
You can use RR. I have actually seen an interesting use of RR for someone debugging a JIT engine for JavaScript. So they were basically recording the entire browser, including the JIT engine, because that's just a C++ application, and you were resuming the state from that. It's pretty heavy in terms of the overhead you're gonna get. Well, twice as slow, so it's not maybe a complete disaster, but sometimes that's the only way if you have non-deterministic bug that is hard to track down.
There's another debugger called the undo debugger, and it's
the record replay was what Matt was just mentioning.
Yeah, I think it records all the system calls. So, and for all the threads, so you can just replay it over and over, and it doesn't actually touch like third-party portals. You just replay, rewind, check other threads, and it looked like you can like figure out problems pretty quickly, but I haven't tried to do anything too advanced.
Yeah, it might.
It supports Java too.
Life has changed since I was hacking C2 and Hotspot.
Yeah, you got 16 gigs or 32 gigs to play with.
Hotspot got award-winning performance numbers on 64 megabyte machines when I started. Gigs, schmigs, what are you talking about? Fine. Yes, but these days these things get big. Okay.
That'll keep your GC pause times down.
Oh yeah. All right. Well, does anyone else want to add? Did you get a link? You didn't get a link here, maybe. Hello.
I did get a link. Yep.
See how bad it is.
It is really bad. Oh, good luck.
Yeah, this is what I was. I can't scroll side to side. Oh, here it is. Oh, geez.
If you do like middle mouse and then like drag in a direction, that should get that.
I got on control arrow keys. It's working.
Oh, okay.
Control plus, and I'm just holding the control key down. I can arrow key around now.
This is just sometimes you want, like, if it's a simple function, if it's like the add function, right? Just adds its inputs. Fine. Do the like thing. Do the graph, right? But if it's like, something more complicated, don't. Just don't. This is my call, like, switch on 13 values and call 13 different functions.
Right. Here's your default branch on the left for your 13 switches. Yeah.
And that's unreachable. There's no default. Yeah.
Commonly in these graph things, memory for a function which is doing a query will have one memory generation point, like your call in the middle of the screen there, and a bajillion readers. And every tail call, every regular call, every load of value and test and load and test and load and test and load and test, they all read from the same one memory because you're just a query function. And so you get 100 output edges. And of course, it's not helpful to look at them all.
At this point, I think you would need to have some kind of interactive tool which shows the hierarchy. And maybe first you just show the call graph and you only expand those things one by one, not just entire thing like on this screenshot here.
Yeah.
For reference, this isn't my IR. This is Yasser's IR. I use his IR in the back end of my just-in-time compiler.
Yeah, this is one of the many visualizations I have, which I don't
Yeah.
find this one very helpful.
Okay.
Yeah.
Yeah.
It can be helpful for little things, but not for this kind of size of
Right.
thing.
Right.
I am
Fair
a big
enough.
fan of the
Well,
textual.
okay, well, now
form.
you said mini visualizers, Yasser. What other visualizers you got?
So
Oh.
the last one I've got is I've got this like basic block parameter one with so let me show a picture of that one.
This sounds like Yorick's basic blocks, which you know, in that particular view, you got no loops there, Yorick. So it's tall by 20, but it has no loops and it has no. Well, you have a bunch of forking and splitting.
This was a simple pattern match of basically checking the equality of some type, so it's fairly straightforward.
Right.
I'm just gonna dump this
That's
in here.
godbolt things. You cut and pasting in here, or should I? Here, I get rid of this.
All right. Yeah, that kind of worked. Let me share the code. It was just well, yeah. So the code behind this was just the code that you shared earlier with the loop. So it's like, you know, a is equal to 1, a is less than 10, a plus 3.
Yeah.
Yeah. So this one is like, this one looks like SSA CFG, and it's basically just me compiling the code, except into like this very like it's basically just running the compiler, like it does scheduling and stuff.
Okay.
Except it doesn't do like register allocation.
Yeah, you're up to register allocation here.
Yeah.
Go to
one.
Yep.
I've got a hate bin of the same code, which is a little bit more readable. Of the code from the big pile, I put it in the doc. Yeah, that's my hate bin. Yep, hate bin.
Never heard of it. Fine.
The image and code pasting website, hate bin.
No, never heard of it.
Oh well, it's got
does it do
got
escape codes or escape codes?
A hate bin?
Yeah.
Yeah.
I don't know.
This is a big ASCII dump. This is
Yeah,
what I was talking about being at some point in the pitch.
It's the equivalent of the previous one though. It is
Right.
that same block.
I mean, I see your yeah.
Oh, you'll see that. Readable.
That is a type check. That is.
I'm sorry. Somebody say unreadable.
No, I said it's much more readable. I like it.
Yeah. Right. Okay. Here, let me turn on hate bin and see if I get a color. Is it gonna let me color things? No, that's a new one.
Hate bin doesn't directly have support for Well, like
I was hoping to get over dark mode versus light mode.
I chose a weird image thing poster because I misspelled hate bin in it.
Well, here, let's see. I do this.
Okay. Yeah.
Right, but this looks entirely like a sane machine code dump, ASCII dump.
Yeah, that's kind of the point.
Right. C2 would do something very similar, slightly different layout formatting, and otherwise very similar. Yeah. And then here's your in-way jump. It's all good. And the unreachable, love that. I'm here because I'm not here.
Well, if your type is something other than one of the types that I'm allowed to generate, if your type isn't 0 through 13, or 1 through 13, if you have a type tag that is bad, yeah, you're going to unreachable land. Like if your type tag is 14 and your dynamic type is 1, 2, 3, 4.
Unreachable means something different. It doesn't mean the compiler knows you can't get here. It means panic with an internal compiler error.
No, it means the compiler can't get here because literally there are 13 different type tags, and if you have a type tag that isn't one of those, you are corrupted.
Right. Yeah, so I've got a distinction between trap and unreachable. So there's trap, which would be like if you hit this, you will explode, and the compiler will like throw an exception basically. And then there's unreachable, which basically just says like if this code path is ever hit, it's not real. And that one actually causes things to, for instance, this is where you get like sort of like CUB kind of stuff. So in this case, it'll be like you'll have a jump table, but it doesn't do the bounce check because it just says that, oh, all the entries, it's never going to miss the entries.
The only case you get here is that you passed in something that is like random number that is not actually a type, it's some other thing.
Well, I was trying to distinguish between at compile time you can't get here because you're type safe, but you hooked it because if you have a compiler bug, you could. And then there's the user can send me crap because that's within the programming model. And if they send me crap, I'll hit unreachable, and I have code there that says panic the user process because the user did a stupid.
Yeah, the panic the user processes are in the loading the pointer calling a different thing. Like if you go to BB3 that's right below this,
Yeah.
which is the BB4,
Yeah.
it does it does a check, and if it's in, it just happened that this was a print function, so you can print anything of any type in my dynamically typed language of Lua. And yeah, it doesn't, this isn't one that yells at you, but if you get like, if you try to add like a function in a string, well, you can't do that. It's going to generate you a block that just calls the you can't do that function, which
Okay,
throws.
that's what I was trying to see. The distinction here is one of these is the user can get there if he does a stupid, and you'll say something then, and the other one is this is a compiler bug if you get here.
It is not only a compiler bug, but it is a very unique compiler bug because it's basically your loading memory that is undefined. It's just that there's very few other cases.
I have things in my system I call should not reach here.
Yeah.
Because I'm writing it in, for instance, Java, and I have to have a default handler, and I put a default handler in, but I know all my cases are covered. So it's called should not reach here. But every now and then I screw something up and it actually does reach one of those. And now fine.
And that's a compiler bug. Yeah.
And that's a compiler bug. Yep. And what is hate bin?
That's why I think it's nice to have syntax for must be dead.
Yes, exactly.
To say,
that's what I'm
look,
doing.
here's a case that the syntax is making me do, but I know it must be dead. And if it's not dead, then error me. Or at least warn me.
I think you have a bunch of background noise, Aaron. Like you may have had to.
Sorry, in a car.
Ah, gotcha. Okay.
Yeah, I don't know what hate bin is. It's just the paste tool I've ever always used. I don't remember where it came from. I just have always used hate bin for my pastes. So if you have a preferred site, I'll start using that for these. But
I don't do the paste thing like this. I usually share code with somebody by some other route.
I didn't want to like dump the big thing into the document directly, but I probably should have, honestly.
Yeah, the doc's fine too, but no, hate bin's fine. How long does it last, you know?
I think 30 days.
Okay, because you'll have a link in the docs and it'll go stale in 30 days. That's the reason going.
Oh, good point. I will put it in the doc.
But it's not. It's sort of whatever. Like I think the point's made here. The giant image shows okay, but maybe it's our largest. It'll be our largest ASCII dump. I don't have one handy at the moment. Other than the one I threw, which is only 20 nodes.
Yeah. It just felt like a long one, so I don't know.
Yeah, that's a good one. All right.
That was one of the features of Microsoft Word I never understood, that you can embed a Microsoft Word document inside a Microsoft Word document. I was like, what? Why would someone want this? Click this link in the document and it will let you download the Microsoft Word document that's embedded in the Microsoft Word document.
Matt, you threw a link in the chat. Did it make it into the? I'm trying to change it in the pipeline up pass. Okay. Anyone else want to do something here?
I have a topic or a question if you want to discuss that, or if somebody wants to go first.
Well, anyone else want to do anything with IRs before I move on?
I wanted to show the IR I have. It's I don't know, maybe it's.
Is this your math nerd reduction one?
Yeah. So it's
It's
I don't
safe
know.
for work if I jump to it, right?
Yeah,
Oh, geez.
So like right now I have like 3 IR formats. There's like, so this top one is like sort of the sequent calculus. And so it's actually very easy to read, but it doesn't have enough information. It doesn't so like there should be like little edges from each of these symbols to each of the symbols like underneath it.
Yeah, the first one, which is the tree of underbars.
Yes.
Yeah, that's not going to scale very big.
Yeah, and so then I have this second one, which is I sort of like rotated it and like I added the information about the edges. So there are these like nodes like X1. No, go up.
Oh, really? Here, this one.
That one, yeah, the middle one. And so like it has the edges in it, like there's ret underscore ONL and all these weird variable names. I just sort of came up with them automatically. So it's more readable, I think, maybe, but like
you're doing some different semantics than a set of machine instructions. So but it's hard for me
Yeah,
to
yeah,
read.
no, it's based on the lambda. Well, it's based on the sequent calculus, which is based on the lambda calculus. So
All
like,
right, so I'm not going to read directly in your, because I don't know sequent calculus, which is fine.
yeah, yeah. So then, okay, so then the third one, you can scroll back down again. There's the graph.
Right.
And so this is the most readable I've come up with. Like I can actually look at this and understand it. And if you scroll down more, you'll there's actually a semantics for how it reduces. So like the double line circle is what's active, and so then like the transformations happen at the double line circle.
Okay. And you're getting more hacks. This is like you're busy reducing.
Yeah, yeah, basically. So, I mean, it's not a full reduction sequence. I sort of stopped once I realized what I was reducing was wrong. Semantics.
This is why you want to have this in an automated way, so you can correct
Yeah,
your
no,
reduction and hit a button and have it pretty print again. Yeah.
These are automated. So I wrote this little Haskell program that generates the graphs. So like, I mean, they're automatically generated. And then I entered the initial graph manually, and then
I'm looking to see if you come down to some final form that looks reduced to my non-reduction sensitive.
Yeah, no, it doesn't. It just keeps getting more and more complicated, and then I just stopped once I realized it was wrong.
Why is it wrong?
Oh, well, so I have these things called dupe nodes, and I realized the dupe nodes weren't working the way I wanted them to, so I have to figure out duplication.
Yeah. I did a lot of stuff with incremental Hindley-Milner where I had delayed unifications, and the bugs would show up all the time. Yes, I totally get this.
Yeah, you can define sequence calculus in a textual form somewhat. If you have seen PLT regex, they have defined typing judgment example. I have posted a link for that. If you can open this cliff, it looks a bit similar to the usual. Okay, you see the defined judgment form. You can see, for example, that you have a types for expression 1, expression 2, the expression 1 that takes T2 to type T3, and you give it T2, then it types as T3. So that's basically typing rule for a function. Function accepting argument for type 2, returning argument for type 3, applied to argument of type 2, returns type 3, and on and on and on. So I think that's pretty readable if you are used to sequence calculus.
Well, the issue is that I mean that only specifies sequent rules, and what I need are sequent derivations. So like the tree in the first example.
So they have the reduction examples too.
Where's it?
In section 1.4, that may be closer to that.
All right, let me go.
You can basically define what the hole is and what it should be filled with. And the hole is literally a hole in the syntax.
Well, so yeah, so in my semantics, the programs are sequent derivations, and so I'm doing reductions on sequent derivations as the reduction semantics, and so it's kind of like 3 levels of logic in one, and that's why it's complicated.
Sure.
So, I mean, yeah, I'm looking at the examples and I don't see anything that would work for a secret calculus. So, or a secret core, I should say. It's all right. Let's go on to Yorick's example, or whatever he was talking about.
Is there somebody else with something going on? Are we done with this topic? I got a lot out of this conversation. This was good.
Yeah, I'm sure I could talk about other topics.
Oh, somebody had something else they're going to say. Yorick had a change of topic.
Yeah, I have. I think it's best I share my screen for that. Let's see if that's going to work.
Might have to hit this. Try again if it didn't work.
Let's see. Desktop. Let's see if it's gonna work. Okay. Whoa. Is my screen visible?
Yep.
Yeah.
Oh wow, it actually
Yes.
works. Consider me surprised. Okay, so this is a problem I've been sort of busting my brain on for like the last 2 weeks. In a nutshell, in my language, there's ownership. So you have owned references that are immutable, etc. Think Rust in that sense.
What is uni?
In this case, that's like uniqueness. It's similar to
okay.
Pony's isolated types. They're basically types that cannot be outside references to it. The problem I had is I have, for example, a clone trait, which is the generic and basically just defines a clone method that just returns t. You specify that when you implement it. So for example, if you want to be able to clone an array, the implementation basically says, okay, well, we implement the clone trait for an array of t. In this case, that t is from the array type.
Favor and change that t to an e, so it's different from the t on the traits from earlier. There you go. That works.
Right. So you basically, okay, implement clone for essentially any array. Here for array. If whatever t it has also implements clone returning t. In other words, we implement the clone trait for any array of whatever value, provided those values also implement the clone trait, which returns a new value.
Mm-hmm.
So essentially, if we, for example, have an array of users, the implementation that sort of translates to is clone of array of user. And then it says t must implement clone of user, or over user, I guess is the correct term, right? In other words, you can only clone an array if the values can also be cloned. That's the basic idea.
You're doing a deep clone.
Yeah. Similar examples like equality, like you can only compare equality of an array if its values can also be compared for equality. This, however, is kind of it. There's two problems going on here. First, it's unsound. And second, there is a sort of reuse issue. The unsoundness, what happened is if I have a array, well, the specific case I ended up with is I have an option type, and it's like a ref to something. And I then clone it. What happens at runtime is it will clone that something as it should, like it will create a new full copy, not a new reference. But it was typed, its return value, as a option to a ref something, not a something. And through that, what happens is it sees, oh, it's a reference. We don't need to discard it. We just need to reduce the reference count. And so it ends up technically underflowing, and then it doesn't drop.
You back up. You have an option of ref something. You clone it.
Let me add
a new option of ref something.
Yeah, let me add the option example. If
right.
t right, same thing basically.
Yeah.
What happens is, for example, I have a option of an option over a reference to a user, right? I clone that. At runtime, that will produce a option user because we're cloning. The problem is that because in option,
between option ref user and user, one is a pointer to the user, one's the user as a value struct.
For the sake of the example, let's say it's more about ownership. But yeah, you can consider pointers versus. Point being, ref user and user are essentially different types in that sense, and they're not necessarily compatible with each other. You cannot substitute an owned user for a reference because their semantics are at runtime different.
Well, isn't that wrong then? Like, shouldn't cloning a type produce the same type?
That's so the problem here is basically what happens is in this implementation, right, of clone option, if I have a option over a user, or in other words, of that option, it's, let me get rid of array, that's confusing. Of that option, its type parameter t is assigned to a reference to a user, right? Because we have an option over a reference to a user, or a borrowed user, whatever you like to call it. What I would like is if you clone that, it does a deep clone. In other words, you get an owned option, an owned user, an owned whatever is inside. What happens is because T is assigned to a ref user, the the return type, right? We have clone. C is basically option T, which means that if we do C, right? So we start with T, but we have an option over a ref user. So the return type of clone is typed as option over a ref user. Because T is assigned to a ref user.
Mm-hmm.
This is correct. Like this inference, this is correct. Rust does the exact same thing because, well, T is assigned to ref user, and we say, well, that's what we want to return, right?
But ref, so what I don't understand or haven't figured out yet, ref user means a borrow.
Yeah, basically. If you discard the reference, essentially nothing happens to the memory it points to.
Okay. And when you're done here, since you made a new user and you're the only one using it, you own it.
Right. So the
Don't
problem
have
is
a reference
it's because
anymore.
it's typed as a borrow, but at runtime it's an owned value. It results in a leak because that owned value is never discarded because the compiler says, oh, it's a borrow. Yeah, just leave it.
No,
Right.
right.
Wouldn't that be not typed as a borrow then?
So there's two issues here. Like first, there's that thing where the problem is basically in this type signature. What you want to say is basically, hey, we want to be able to clone whatever, and its output should be an owned equivalent of whatever
Owned
T
equal-
is.
yes, yes.
Right. So in other words, what you end up is you basically want, instead of implement clone option T, you want something like, oh, actually it's an owned T, for example, and then similarly, whatever value is wrapped should also return an owned T, not whatever type it's originally assigned to, right?
Right.
That, however, results in also soundness issues. In the sense, I had the example like, so you end up with this problem where I remember. Okay, so we do that, right? So we say, okay, well, we want an owned T. So our clone method would then look like something like option owned T. And then, whatever the implementation is. The problem is, if I have, for example, a option ref user, it will look up its clone implementation. It will see, hey, we have implemented here clone yada yada. Then what it would do, because we have owned here, it would strip that off. So you end up with, instead of without that, you would end up with essentially an implementation of clone ref user. But because we stripped it, you end up with clone user, right? So far, so good.
No, I don't understand why you stripped it, but
Because of that own. Essentially, that says, whatever type is assigned to T,
yeah,
whatever ownership, basically strip off the ownership and give back an owned version.
Yeah, again, I don't see where the strip off happens. It's like, if my C is defined to be an option of owns T, well, it's an option owns T. It's not an option T.
So imagine that you have, an option, you have T is ref user, right?
Yeah.
Well, if you say owned T, that becomes a user. That's sort of the idea.
I
In a
understand,
sense-
but what is semantics that says that I can take a ref user and declare that I own it, and the other guy who was the owner no longer owns it?
Not sure I fully understand.
Okay, I understand ref user to mean I have a pointer to a user struct. Somebody else is maintaining the lifetime of that struct, not me.
Right.
And when I quit holding on to my user, my reference to it, that other guy will, at his whim, delete it, recover the storage. And I don't have any say over the lifetime, but the compiler guarantees me the life remains as long as I got a pointer to it. But I'm not the guy who's having to deal with it when it's done.
I'm a little curious. Put it this way. The core idea of what I wanted is basically I have, let's say, an option type. It wraps a value.
Yeah.
That can be a reference, it can be an own value, it means, whatever. What I would like to be able to express is say, hey, if you clone that, you get fully new copies of that, even if the input was basically a reference and a mutable reference, a whatever.
Yeah, but
Right.
you can't. I know what you'd like to do, but I think you can't already because you just pointed out.
No, so the problems I ran into is basically, it types it wrong. Well, technically, it types it correct, but it allows certain things that are not allowed. And specifically, what I had this hack where if it's Surface where I have this case where I have two values. I have a reference. I have two arguments in an equal function, for example. Those arguments are defined as a reference to something. So you end up with like fn equal. I say a, and then I say left ref a, right ref a. This originates from this used to be like an equality function, a unit testing library. So you want to say, hey, are these two values equal, right? Well, for that to work, we have to say, well, A has to implement equal, and it has to be equal to itself, right? Because you can't compare an integer to a string. What happens here is if I pass, let's say, if I pass, let's say, a reference, so I do something like equal ref blah ref, I don't know, foo, whatever, right? A is assigned to that ref, whatever the type was. What it ends up doing, the requirement then becomes equal ref xxx, because A is assigned to ref xxx. This led to a problem where in most types, what you do is you say implement equal over whatever. You don't say implement equal over ref whatever. And that then creates a problem. Well, if I implement equal over something and I give then equal over a ref to something, that's not compatible. Like those are different things. So I had this hack where basically, and I don't fully remember how past me came up with that. But the idea is basically that requirement of that restriction, like, hey, you can't pass a ref when a known value is expected, that was allowed for this case, for trade implementations.
This is like, because you're not allocating anything new and the allocation doesn't change, you can throw the allocation modifier away and just take my two xxx's or my two a's.
Right. So the idea is that in this, in these cases, that's fine because you sort of can quote unquote dereference the implementation.
Yeah, right.
But then you end up with this case where I have an option over a ref, I clone it, and it still types it as a ref.
Yeah, no, but as soon as you said I clone it, what you said was I made a new thing, but I have ownership types, so all my types have some sort of ownership. As soon as I make a new thing, right, I got a different type. I got to deal with the fact that it's a new thing. I own it. Whatever it was before, I now own this one.
The way this is sort of handled in Rust is it's through a combination of being able to implement a trait multiple times for a type, and this idea what they call blanket trait implementations and dereferencing. In other words, what you do is something like impl clone option t for option if t also clone t, and then the idea is type parameters by default are sort of owned. Like, in other words, in this expression, T means it's an owned T, not a reference, not a whatever.
So you didn't write the word owned, but there's a default that says...
Right, let me just add it for the sake of clarity, right?
Yeah.
What Rust then essentially lets you do is something like, oh, well, we can also implement clone over an option of a ref T, provided that T returns a clone of a ref T or an owned T, for example. Oh, we can also do that over mod. We align this a little bit for clarity, right?
Okay, so on the ref version, it's okay if it has an owned T. I don't understand how that works.
Actually makes the most sense to me, because that's just like template specialization in C++. You are saying that for the reference, you have a special case when it's not going to be a reference when you return it, because now you own it because you clone it. As a reader of the code, this makes the most sense to me.
Right. So this is what Rust lets you do. You can implement basically unlimited combinations of a trait for a certain type and then set your constraints. So you can say things like, oh, if I have an array of references and I clone that, I want an array of values, not whatever those references point to. Oh, but if it's this other type, an array of whatever else, then I do want returning an array of references. So you can have these really flexible implementations.
Okay. All right.
Now, my language doesn't allow that. It's more, in that sense, more similar to, say, Java, where if you implement an interface, it sort of implements like the base of the type or the class, if you will. And that can only be done once. And so this creates a problem where I somehow have to express essentially these 3 lines in a single one. And that's where you run into these soundness issues where things are typed as one way, but at runtime they're different. Because of this hack that I had.
But this sounds like a self-inflicted injury.
Right, so I can remove that hack, which I should, because it's a hack, right? But then you end up with this problem. If I say imply, let's say clone option T, right? For option, let me just copy this.
Could your structs have references inside of them?
Yes.
That sounds like it's gonna break when you try to clone as well.
Well, so the clones is essentially, user defined, but the intention is a deep clone. So the sort of goal is basically, whereas Rust lets you do these multiple implementations separately with all kinds of complex requirements, which effectively requires overloading, which is something I desperately want to try to avoid. I somehow have to sort of encapsulate that in a single implementation where I can say, hey, implement clone for option for whatever, T is assigned to, as long as if you clone those T's, you get a new T, not a reference or whatever.
I don't know how you can do that because, overloading is essentially a form of ad hoc polymorphism when you want to have special case rules for types like T versus ref T, and that's exactly what you are going for. You want to have ad hoc polymorphism, as far as I understand, because it would be a lie. It would be unsound, as just said, to say that we get ref T here.
Right, and so the Rust approach is one solution, right? You do overloading, you allow traits to be implemented multiple times. The thing is, then you need some sort of need a scheme where what Rust does, for example, if you want to, for example, implement hashing for a type, I don't want to implement that 3 times. Once for the owned equivalent, once for an immutable reference, once for a mutable reference, yada yada yada. Rust lets you write things like you implement it initially for the owned equivalent, then for the reference one, but you sort of dereference it back to the owned one. So you don't have to re-implement the whole hashing logic. And then they have this concept called blanket trait implementations, where you can say, oh, implement this trait for any type, as long as that type meets these criteria. I guess another way of kind of seeing is kind of in Haskell, you have for all, with like implementation, we say, implement this type class for all T's if they have, these requirements. That's sort of what I'm looking for, but ideally without actually having to support overloading, specifically because that requires rather substantial compiler changes.
Yeah. Okay.
And you end up with this, I think it's usually referred to different names, but like in Rust, it's called the turbofish problem, where if I have like a common case in Rust is an into method, which is overloaded by, trait implementations. If you look at just that expression, it's not clear what we should convert into. So in Rust, you end up having to write something like, oh, we want to convert into a string, for example. It's referred to as the turbofish problem.
Separately, I think into is a bad idea, but okay, fine.
Right, but the idea is basically there are going to be cases where you have to disambiguate the call side because the compiler can't figure out, which one of these 15 overloaded versions do I need to use. I really don't want to go there. So it is a self-inflicted problem in the sense that I want to avoid this big ball of complexity. But as far as I've been able to find, there has not really been any work done towards any alternatives. More precisely, Rust is basically the first language doing this. Yes, Cyclone existed or whatever, but
have you looked at granular language?
Never heard of it.
Never heard of it.
Okay,
That means a link.
I will post a link. So Granule is a language that has both linear types and uniqueness types.
Hmm.
Remember that one will guarantee you the no reuse about the past. The other guarantee that there will not be any copying or cloning in the future. So basically one can say that you don't have any forged references, whereas the other says is you're not gonna duplicate types. And Granule has a pretty advanced ownership system. I think the author even works on fractional ownership. And I know it has a maybe type. So maybe it would be interesting to see what Granule does, or even ask the author of that language, because they pretty much had to have a similar problem to what you are having.
Yeah, no, that sounds interesting. I'll take a look. But so over the week, I've been looking at sort of variations of trying to figure out, how do you approach this problem so that ideally, as a user, you write a single implementation, your clone, your equality, or whatever. And then somehow the compiler can figure out, oh, if I have a bunch of references or an array of references, then it's safe to also reuse that implementation, such that you don't have to basically write the same thing multiple times. There, like, essentially two variations I had was one, in these implementations, T, for example, the type parameters, by default only allow owned values. So here on line, what is it, 12, I've owned T, that would basically be implied, essentially. So then your implementations are much more strict. Like you have to decide, hey, these type parameters, are they going to be owned? Are they going to be references or what? But then you run into that reuse problem where if you say, well, we can only implement a trait once for a type, you have to decide what is the ownership going to be of these various type parameters. And from that point on, that implementation can only be used if those criteria are met. And the case where this gets annoying is if I want to, I have a hash map. The requirements of its keys are that it implements the hash trait, which is just, to generate the hash code for that value, and the equal trait, so that you can compare those keys for equality. The trick thing here is if I say, well, type parameters are owned rather than anything, essentially. If I implement equal over a type itself, I have to decide, hey, do I want to implement that equal trait over a owned version of itself, a reference, or something else? Which means that if I do something like, impl equal, let's say user, for user, whatever, I can then not store a ref user as the key of a hash map, because a user implements equal user, not ref user.
Hey, you put ref user hash maps lifetimes limited to the keys, which you don't have.
Oh, so lifetime here is like, imagine, instead of lifetimes, we just had pointers, right? Forget about the lifetimes. It's essentially,
yeah, if it's pointers, you just want two copies. One that takes a user by pointer and one that takes a user by struct that's, jammed in registers or something.
I think, put it this way, if you
versus ref semantics.
If type parameters, for example, are owned by default, unless you say, hey, it's a ref, a mut, whatever, you run essentially in this setup, in this problem that in certain cases, you cannot use certain things as refs because the trait has been implemented over an owned equivalent of the type, and we do not allow multiple implementations. So that's sort of what led to this problem. The other idea I played around with is that type parameters stay as they are now, meaning that they can be a ref, they can be owned, etc. But you would introduce this, owned keyword, or in my case, I used move because you move ownership, and I already had the keyword. But then you run into soundness issues elsewhere, where essentially the problem is if you have a implementation of a trait, it is not safe to sort of change the ownership of certain type parameters in different places. Like the case, for example, it's a bit annoying because I have a long list of comments listing all this out, and it's like trying to consolidate this.
Yes.
Effectively, what I'm looking for is a way to be generic over both type and ownership, while still being able to express in certain signatures, hey, regardless of what this thing originally was, what the ownership originally was, it should be an owned value. So that you can say, hey, if I have an option of a ref, an option of mutable ref, whatever, if I clone that, I get an option of an owned value.
My current solution is pretty bad. I just don't allow it. So
Don't allow
That
what
problem.
specifically?
like any cloning whatsoever, and anything that requires something that looks like C++ templates.
Right, so you don't have generics, basically.
Yeah, basically.
Right.
Yeah, this is, I mean, I think this is not the generics problem per se. This is an ownership problem.
I think you can categorize this basically as a subtyping problem, in the sense that it is, you can see a similar problem if you have, for example, I have to say it correctly, a case where if you have, say, an equal method and its argument is typed as a trait. I'm saying, no, fuck, never mind. Put it this way, it's similar to subtyping problems where in certain contexts, certain subtypes are compatible with their parents, but then depending on how it's used, the other way around might not be valid. So
I may be missing the problem here.
Yeah.
But it seems like the function clone is just a function that borrows some value, allocates new memory, returns unowned the thing in the newly allocated memory, and then returns the borrow.
Right.
So that whoever calls clone needs whatever their thing is to be borrowable, and they get back a thing that they own. So why is it a problem that the argument is a borrow and the return value is a new returned thing?
So that's the funny thing. The runtime implementation is completely correct. Like it does what it should do. The way types are inferred is also completely correct. It's just that I sort of allowed it to the combination of the two because of a hack that was used to sort of work around things where I couldn't find a better solution. And for most cases, that hack is actually fine. But it's this case where if you want to essentially move from a borrowed type to an owned equivalent, the compiler will still see that as a borrowed type. And so it ends up basically generating the wrong code to manage those borrows. In this case, it results in a memory leak because it sees a reference, doesn't do anything with it, but the own value is sort of forgotten about. I think I can.
You said that your implementation was perfect, and it's not.
No, the runtime, what it does at runtime in terms of cloning, that's correct. Right? It takes a reference and produces an own value.
It misses the reference. That's the runtime.
You got two parts that are not compatible with each other. Each individually does what you want, and taken together, they do not do what you want. And now change one or the other or both.
No. So the thing in terms of the logic used for cloning, that is correct. Right? It clones correctly regardless of...
It's the typing. I think the dynamic semantics are correct, but the static semantics may be unsound.
Yes.
By the way, maybe take a look at what Swift does with conditional conformance. So conditional conformance is, for example, if you have an option of equatable, then it's going to implement an equatable if the type that is wrapped is itself equatable, which is, I think, what you are going for here. And they actually had to recently make this optional array and dictionary types conditionally equatable because they were solving similar problems. And from what I could see, I have posted a link. You see the third line, the one that specifically refers to the implementation of optional in the Swift standard library. They do have a specialization for the wrapped type. So optional itself may be of a wrapped type, and then they implement the equatable for the entire optional. The wrapped type is equatable itself, and they do rely on the equality coming from the equatable type. So it does seem you have to do some kind of specialization or special case handling for that kind of thing.
Right.
I don't know if this would help, but in my compiler, usually have things as hints. So you can basically hint that this wants to be a copy instead of a reference. Like you can still pass it as a reference like you're doing now, but just drop a hint saying that you want to make this into a copy.
Was
But
this
I
like
don't know how it's going to help your situation.
but this is like an optional thing. If I fail to add it and it's just incorrect and I leak, the hint is and also I'm changing the types here.
Yeah, the hints is more for hacks.
Yeah.
Yeah, I think it's the core of the issues. Effectively, what you need is a way where you implement a trait and you sort of duplicate that for your different forms of ownership, at least where that is possible, without physically needing to duplicate it. And Rust handles that with a rather complicated type system where you can say, oh, automatically implement this, if that, and things like that. Such that if I...
Why is it a property of the values rather than a property of the container? Shouldn't it be the reference or the option or the list or the map's right to say, hey, I'm the kind of map where if all the keys and all the values are equal, then they're equal. I'm a list where if all the elements at each index are equal, then the list.
Let me see.
Like it feels like option could define the fact that if you have two options and they are both options of the same value, then they are also equal. And it's just a container that believes that its equality, it is equal if everything it contains is equal.
Yeah.
Yeah. Not sure.
Like, why is it the type that is contains choice rather than the container's choice?
No, it's not so much that it's the contain values choice, but if I, for example, have a option of whatever, I still need to be able to check if those whatevers are equal, right? And how that is done depends on the implementation of equal for whatever. Now it is true that if I, for example, have a if I have an immutable reference to two whatevers or immutable references to two whatevers, the equality check is the same. Right? The logic, because they might check some internal stuff. It's that effectively what you need. Gosh, how do I sum this up?
Combination. I think you need to have a combination. I mean, think of collection and conditional conformance of a collection of types to be hashable. You can only have this hash for the collection if you have the hash for the individual elements. And then on top of that, you also have to have a hash combiner function that combines the hash values. So you need to have some layer on top of it all.
Right. Yeah, and basically what I want to go for is somebody says, hey, implement clone for option of T. But I don't want to, I don't want to give a damn if T happens to be a reference, an immutable reference, a unique type, because for the cloning purposes, that doesn't matter. So essentially what I want to say is implement clone for option T for all T, whatever it is in Haskell.
Wild card on your ownership type, separate from the structural type, like T is a user or a string, and then there's the T is own mutable ref. Those are two different polymorphic variables, right. And you want to wild card on one, and the end result is an owned.
Right. Yeah. And so the latest idea I have is basically you add the ability to essentially flag a type parameter as being owned. So if it's originally a ref, then if it sort of goes through that keyword, it turns it into an owned version. But then you would have to restrict that so that it can only occur in return types.
Mm-hmm.
And you end up with this, because the way it's implemented, you end up with this case where you cannot take as an argument something that says, hey, strip off the ownership and use it as an argument, because that's incorrect. Because I would be able to pass a reference and this function is, oh, I magically turned it into an owned version. It's like, no, you can't do that. Output is fine, right? If I have a reference, I can output it as an owned value by virtue of cloning it or whatever. But then that felt like a rather odd solution. Though funny enough, the paper that Inko's ownership model is based on from 2006, it specifies exactly that. So it's like, okay, I guess I wasn't too far off. But yeah, I was basically curious to see, what are potential alternatives. I think Matt shared a whole bunch of links there, so I have some homework to do there. I think the crux of it is that, generics over types is difficult. Generics over a mixture of types and ownership, like, dear God. I think it's a good argument against having ownership, because it does simplify your compiler, but in doing so, you introduce other challenges, of course.
Hey, Yorick, just say it. Matt, I only copied some of your links. You want to make sure I got all your links into the doc. Because the chat's not necessarily looked up everybody. It fades.
Is there a way to sort of...
Sorry.
Is there a way to sort of pop up a level and say, the problem here is not necessarily .clone, but just in general, when you're trying to do an operation that takes a t, and I have a reference to the t, or a reference to a reference to the t, or a L value from a map of a t, that all of those things just have some concept of, oh, I am a container type, I am going to unbox myself, we're going to drill down to the bottom actual thing, and then it will just work. So that anytime you say, hey, is this reference to a t equal to this t that exists in a map at a key L value, that the containers just go away and the comparisons fall through to the actual items.
That's why I have a lot of hints in my type system in my compiler.
Yeah, so that's essentially what I am looking for. And Rust achieves that through its combination of basically overloading blanket trait implementations and just generally
I mean, it
very
sort of
powerful.
achieves that. I've definitely had times where I had to implement on the same class both a from string and from pointer to string, from vector of uint8s, from pointer of slice of uint8s.
Right, so there
There's
are
a lot of things that are
limitations.
at bottom a slice of uint8s.
I know you're
but
not talking about C++, but this is such a C++ problem.
I mean, I think like essentially also what Yorick said, it's the problem is you're only like first you have being generic over types, and then these types relate to each other in some ways. So you want to be reusable with respect to ownership. And this feels a lot like subtyping, and then suddenly things start to become ugly. And I guess also in Rust, this like it gets even worse because you have, on the one hand you have ownership, then on the other hand you have lifetimes, and then you have these higher rank like
it's kind of like
yeah.
You have the covariance and contravariance problem
Yes,
in polymorphism,
exactly
but instead of types you have this over lifetimes, and you're trying to figure out what should happen with the lifetime polymorphism.
Right, I actually think like I think it's actually pretty rough going the Rust way, because like you if you can mix, like let's say you have ownership and lifetimes and you have these covariance and contravariance issues, and then you also have to think about closures, which like flip many of these covariance rules on their head. So yeah, that's just reading through the implementation of this it's rough. So I sympathize with you. I think the idea of stripping off, or like saying the return type is owned, I think is a cool idea. But I have a question. Do you have you identified more traits or more examples of in which this your way of doing it, or your second plan is useful? Except like equality and clone, or
so I've used these because they are the cloning one was the one where it sort of surfaced, because that's one of the cases where you go for whatever you have as input and you want to sort of narrow down to an owned equivalent. It's kind of tricky because it's one of those problems where the examples you run into are quite specific, so it's very tempting to make very specific solutions to that. But what I've sort of learned thus far with at least type systems is that when you do these sort of very specific hacks, they will work for like 3 months. And then this exception pops up and you're like, okay, let's do a quick hack for that. And another exception 3 months later. And then you're like, oh crap, now I have 5 weird edge cases to deal with.
Fought that bug many times, yes.
And
back often, yeah.
So my approach has now been sort of shifted towards more like, okay, I'll do that once, like a hack if I run into this while trying to solve this bigger problem. I may be like, you know what? I'll add a quick hack, log an issue, I'll look at it later. In this case, that happened to be like a year later or something like that. But so now I'm kind of looking for like a generalized sort of catch-all solution.
Mm-hmm.
But it seems that comes down to either you need a form of overloading and sort of dereferencing like what Rust does, such that you can have all these complex implementations and do things like, implement hash for any type or any reference to any type if it also does this, or etc. Or you end up with what I've seen so far, this type system where, let's say 80% of the code is you write it as you would expect. But then the moment you have, for example, these generic containers, you have to tell people, oh, wait, if you want to do this, you have to start adding these annotations in different places and yada, yada. And that might work. It might be correct. I still have to kind of figure it out exactly. But it's one of the solutions where people look at it and they really raise their eyebrows. They're like, why is this so different from everything else? Why it's so complicated? And that's where I typically try to figure out, okay, if that kind of put it this way, if there's these sort of exceptions in your type system where it's like, oh, this context, it means different things, or if you have to add keywords, to me that's usually an indication like, hey, there's something I'm missing. There's some sort of bigger solution possible. This isn't always the case, but
the thing that it's making me think of is in Python, they wanted for to be able to work on basically anything. So what for does is call .iter on whatever you put there and just be like, hey, can this thing turn itself into an iterator? And then once it's gotten that iterator, it calls .next over and over again until it gets the stop iteration exception back. I almost wonder if you could build a structure that was like, hey, thing, I would like to test you for value equality to something. Give me back the value equalser. And then once I have called values equalser on both sides until I got down to something that believes it can do values equals, then I'm going to actually call the equals on the two values that got to the bottom on both sides. And say, no, it's not that every type in the world needs to be able to handle this case of am I equal to and get the other thing. You just need to say, okay, thing on the left of the equals, thing on the right of the equals, I'm going to call give me the values equalizer, and I'm going to drill through however many layers of container are there until I get to the bottom. And then when I've gotten to the bottom on both sides, you can just say, okay, guys, are you equal? Try calling equal by passing the left to the right, then try equal by passing the right to the left.
So in the ecstasy model, the equals is defined at a point in the class hierarchy. So subtyping, there's a hierarchy. You define a point where you're going to compare things. They can be subclassing. They might have a different lowest common ancestor in the subtyping tree, but you've picked a layer where you're going to do the equals, and that's what at the compile time known, not the dynamic runtime type. And that means that you call equals at a point in the class hierarchy and you hand it to subclasses. But they're both, they implement the place you're at, but they might have a common point further down, least common ancestor that's lower in the hierarchy. And so calling left to right or right to left doesn't matter. I mean, it's symmetric and it doesn't change the answer if you call left equals right or right equals left, because instead you're calling this base class is equals for A and B, who both implement base, but they're both subtypes of some kind. So I don't know if that helps. That's equals versus what I hear Yorick doing with ownership, which I'm inclined that keeping the ownership as a similar level of what types mean for strings and person objects and point objects. They're different things. And I think it's sensible to say, I'm going to treat them differently. Those two parts of the type are treated differently.
This question might make no sense, but did you implement Yorick? Did you implement short circuiting, and was there a lot of special cases in that?
You mean for equality?
No, short circuiting for and or.
Yeah.
Oh, I mean the operators.
Yeah.
Yeah. So they're in the current version they are your traditional short circuiting operators. In a very past version, there were no such operators. This was back when it was drawing more inspiration from Smalltalk. Like there was no if keyword, there was an if method. And it took two arguments which were closures, which performs about as well as you would expect. I eventually moved away from that for a bunch of different reasons.
Inlining, it'll save you.
The actual implementation of short circuiting is fairly straightforward.
You only have.
So I'm not sure what the
Booleans in your-
specific question is there.
Oh yeah, you only have Booleans in your short circuit. Like
I don't do things like
Okay.
string ampersand or whatever.
Yeah.
You can do
That
that.
was my question. If you had a string and foo or user or whatever.
No, so
just-
I do have. Sorry, so the and or keywords only support Booleans.
Okay.
I don't remember if I still allow the syntax to define double ampersand. But all the other operators, they are basically just methods, just syntax sugar.
See, I remember having that as a special case because depending if you did it in a global scope, it would have to be a constant. So it would have to the variables would have to also be constants, and everything was just treated differently.
Why is global
inside of-
scope requiring constants? I'm confused.
Because I want like a yes or no at compile time and not to.
Oh, you have two different operators. You have a compile time and a runtime and.
All right, I get it. Yeah, so at the way operators are handled at runtime is they translate to method calls, and eventually when I will implement it, they will just be inlines and those method calls go away. Right now, not done. So if you do 10 plus 5, that's an actual method call. It takes up quite a bit of time.
Yep.
In constant values, it is just special cased by the compiler. My constants are limited to string, ints, floats, and arrays of those values. And somewhere in the compiler, it basically says, oh, if we have, the expression a plus b, check what the types of a and b are. If those are not in the allowed list, produce a type error. And then we say, oh, if we're doing if you do int op int, compile this way, etc. So it's basically a compiler pass that traverses the nodes of constant values, and then there's a little expression evaluator in it. And the semantics are the same as at runtime, but it is technically different code.
But it sounds like a C const expr.
Yeah. So if I do 10 plus 5 plus whatever, at compile time it collapses that into the final value.
Okay. Yeah. All right.
Okay, yeah, no, that makes sense to me. The short circuiting is where I use my hints, but you did two separate pieces of code. So yeah, I'm not 100% sure how easy it would be to implement some kind of hinting system, but yeah, I'm not sure how to solve your problem.
So I guess what I'm hearing there is you're wondering how to do like Boolean short circuiting at compile time?
Well, one of the first things I did on my hinting system was to say, do not generate code when you do the short circuits. You just want to generate a constant. So it's the same piece of code, but it will just check the hints to see if it wants to generate code or if it should exit early and give a constant. So I end up using the hint system in multiple places. I think ternary operations was in our place. I gave a hint of, do I know, like, is there a left-hand value already? Or do I have to deduce it? And it runs like an extra piece of code if you know what the type is, because you could just, like for example, with an enum, if I know what the type is, and I just have a word, I could just look up that word in the list of if it's like one of the values in the enum, and that's all good. If I don't have that, then I'm assuming it's a variable, and if it doesn't exist, I give an error. So I just use the hints a lot, and uh, but this doesn't sound like your code has like a system for that already. So I'm not sure if my suggestion earlier would help.
I don't think so, in the sense that in Inko it's the compile time evaluations are extremely rudimentary. It's basically just constant expressions of in float string, etc. And that's really just so you can have like a constant with a big array with some numbers in it, where you refer to some constant and you add 5 to it or something like that. There is conditional compilation, but it is again restricted to conditional imports. So you can say import this module if we're on Linux and we're using x86 64. But there's nothing like Zig's comp time expressions or Rust macros or anything like that, where I can do like compile time type inspection and things like that. That doesn't exist, and don't have any plans to either.
I didn't mean that in the runtime. I meant in my own compiler. I just have one piece of code, and it just handles both cases. And it's not passed in as a parameter function because there's a few reasons why, but yeah.
Well, I'm going to propose that we start winding down here.
I wanted to make a comment. I don't know. It was a while back. Yorick was talking about Rust Turbofish into thing. So there's this paper called "The Second Look at Overloading," and they actually have, I want to say it's not the definitive solution to the type class overloading return type problem, but it's a solution, which is that you just prohibit type classes that have parameters in their types that do not appear as arguments. So
okay,
and so then you can just determine that the types of all the parameters, and then the return type, and then it's fully typed, and you don't need to any deal with Turbofish at all. So.
Yeah, so basically they require, I guess, type parameters to actually be used as part of a call. Yeah. Right. That's I haven't implemented that. I do eventually want to do that, in a sense that if you have a a generic function, you define some type parameter t, you just return it. Well, right now that will throw a compiler type inference error, because it's like I don't know what the hell this is. But I've yet to make that a hard error at the definition side. But I agree. Like, I think return type inference is a very cool thing to have. It's one of those things where you're like, whoa, this is exciting, but I'm like, I prefer not to have it, because if you have to deal with disambiguating that, it's not fun.
I came around with that as an option at some point, and I explicitly have it turned off, but I could turn it on. But I was just thinking it makes it hard to understand how the code is typing. Like, if it's successfully typed, it would still be difficult to understand why it typed. So I was saying, no, I haven't coded enough in anger with it to know if it's a good answer or not.
So what do you, actually, I haven't thought of this question that well.
Well, save it for next time. Let's close up here. I think we're at a good point. Darrick, you came in late. Did you want to add anything, or?
Well, I was going to mention about this return type inference and stuff, that I still have my piece in place where I sort of wire in all my call sites for the graph and try and optimize it all together as one huge blob. And I don't know, it works okay. I can do it every now and then. It's a source of interesting and exciting bugs. But they're sort of getting squashed out. But it definitely slows things down. I realize if I have lots of calls, it just creates such a tangled mess of graph that it takes quite a long time to like work through
I'm not
it all.
going to say closure or anything, but closure.
Well, yeah, I mean, there are lots of things that I did that make things take longer, and so they add together to like make some compiles take quite a while. I'd say they probably multiply together. But you know, it's still manageable. I'm thinking about, you know, in the end, I inline all my function calls pretty much anyway. So all that stuff that I do seems semi-pointless. And the only reason I keep it is because I'm thinking, well, probably I won't be inlining everything forever, and then that's when it'll become useful again. So right now it's just this sort of annoying thing that's does lots of work, then gets thrown away because the function gets inlined anyway. And yeah, that's sort of where it's at. But
you might have a performance on asymptotic algorithm changes if you're doing some work you're going to replace later. It ought to, the work you do in pre-inlining and post-inlining ought to be one of the same. It's either side of the inlining equation. Maybe there's some thinking about how you're structuring that. Yeah,
if it's successful, but you know, it's basically because everything is wired together, then there's you know, these giant there's giant fees that are pulling in lots of different types of data into functions.
Yeah, as soon as you wire it together, you get a lot of opportunities to clean things up.
Exactly. Yeah. So yeah.
I wonder if there's a way to do return inference for the compiler errors, but not for the happy path. And be like, well, I'm going to give you an error that says, hey, if you had made this thing this type, I would be happy.
Oh, this is like...
That's a weird thought.
I compiled you, I got an error. I'm going to throw an error at you. Okay, wait a second. Let me turn on return type inferencing and try again. Oh, it disambiguates. I can figure it out. So your ambiguity stems from the fact that you didn't give me
error.
Return type.
There's exactly this change that you need to make it happen.
Right. And your ambiguity.
But don't leave that in your code base. That's not going to help humans reason about your code.
I am not going to try to tackle that one today.
If the compiler can turn the feature on and then disambiguate, like, shouldn't it just carry on and not return?
You're right. Why is the compiler giving you an error? No, okay, you were here for that. It was just like, my theory is that if you do return type disambiguation and it works, it's still hard to understand. Why did it make this, you know, one path disambiguation returns is fine, but you'll get a chain of 10 in a row. And like, fuck, it worked, but what the hell is it doing? Right. Give me a type on somewhere.
Yeah. Even ChatGPT cannot understand this code.
Yeah, exactly. All right.
Yeah.
I'm gonna call it quits.
I think it's perfectly valid to say this code is good enough for the compiler, but not good enough for a human. Please make this change.
That's correct.
Oh, yeah. That's basically what I was going to ask earlier. I just wasn't sure how useful return inference is and how confusing it could be.
Well, let's go type rust.intos until you hate yourself.
I guess it depends what you're doing as well. Like for me, I'm not using it to select which function's being called. I'm just using it to provide more information post call site.
Okay, no, I'm using it for which function got called.
Yeah.
The .into string or the .into person or the .into JSON.
Yeah. But I have to say one thing that, you know, I have this sort of hybrid compiler structure, which is a hangover from having started with a like multi-pass nanopass compiler and then switching to graph for the optimizer. Well, the IR is such a giant pain in the ass compared to the graph. It's so annoying to work with. Even though it's easier to write the graph like rules, like the transformation rules, it's like, I know the information is there. It's so hard to get it.
There you go.
The info is right there.
Sea of nodes from start to finish. That's my theory. Fine.
Yeah, well, next iteration,
Next time.
I'm actually like so close to done, like in terms of V1.
You only got the other 10%, which takes 90% of the time to do.
No, it's not even 10%, it's like 1% or less. It's like it's just bugs in annoying places that are really tricky to think through. And usually it's like already out of the sea of nodes. So now it's like I've got a beautiful graph, it looks right, like it's amazing how well it figured out what I meant. And then it's like, oh, the register allocator doesn't have this info that would be useful. Like, how am I gonna?
Don't go there. Stop. All right.
Anyway, yeah, I'll complain about it.
Good CCC till we meet again next week.
Yeah.
All right. Bye-bye.